So I've removed the keyboards from the organ now and got one of them onto the bench. So let's take a quick look. So there we are. It's a metal framed keyboard, they both are. Quite heavy duty actually. So let's flip this keyboard over and see what we've got and how we're going to connect it up. Okay, so here's the underside of the keyboard. It's got a printed circuit board that runs all the way along. There's a diode for every key, so that we know straight away it's a diode matrix type of keyboard. And if we look at the actual switch configuration here, we can see that there's a metal bar that runs along there covering the first 8 notes, and then there's another one for the second 8, another one for the third, fourth, fifth, sixth, seventh, and then for the last one it only covers 5 notes because there are only 61 notes on the keyboard. So the way that this works is when you press a key, it lifts up one of these little springs and that actually touches this bar, thus making a contact. And then there are 8 of these in each group. So what I'm going to do is zoom the camera in a little bit and get the meter, and we'll take a bit of a closer look exactly how that works. And then at the end here, interestingly, we've got 2 connectors, but there's also a chip here and a little capacitor. So we'll have a look at what that does and how we're going to connect to it. Okay, so to take a closer look at how this works, I've got it propped up on a couple of boxes that you can't see just out of shot here, but basically if I press a key, you can see that it lifts this little spring which comes and touches onto this common rail here. We looked at those just now. We said there are 8 of these common bus bars, common rails, call them what you will, but the point is that when you press a key, it pushes this little spring and it makes contact with that. So that's pretty much what's going on. And just to prove what we're saying, if I connect our meter to that common bar and we press a key, so let's go with this one, if I connect the other side of the meter to that, then when we hold that down you can see that that's making contact and the meter bears that out. Likewise with this one here that doesn't seem to work, which is interesting. There we are, just a bit of a bad connection I think. That was one of the issues actually. The customer did say that some of the keys don't work, so we might have to give this a little bit of a clean up or something, but we'll see how we go. Anyway, this end of each key is connected to one end of this diode here, or these diodes, so that is connected to there. So the idea being then that if we connect that to this side of the diode, find that right key, then we get that reading on the meter showing the forward voltage of the diode, or forward resistance, whatever it is. Now the idea of having these diodes, let's just find a couple of notes next to each other, there we are. So if I press that note and I press that note, obviously when I do, the springs connect to this common, but if I press them both at the same time, it now means that both these notes are connected together, which isn't really what we want. But because we've got diodes in the way, that's no longer the case, because the electricity can flow this way through this diode, up here, across the bar, back down, but then it can't flow back again through this diode. So that's why we have the diodes. And that becomes a little bit more obvious, hopefully, when we look at the fact that the diodes are also, or these groups of 8 if you want, repeat all the way down. So for example, if I take the leftmost one of this group here, which is just about in shot actually, is there a, yeah, let's use, hold on, yeah, that's easier, we can see the whole thing there. So if we take this bar along here, the left hand switch of that comes down through this diode to this point here, and then if we come along to the next bar, the leftmost switch of that one comes down through this diode to this point here, or that point there actually, but they're repeated. So this point is connected to this point. This side of this diode is connected to this side of this diode. And that's the same all the way along. So if we go along by one diode there, come along by one diode here, they'll be connected. Along by one there, along by one there, and so on. And by doing that, we end up with only 8 connections for all these diodes, because for each diode, each group of 8 diodes are connected together, if that makes sense. So that's one side of our matrix, if you like, are the 8 sets of diodes, and the other side are our 8 common bars running along there. So we'll move this around a little bit so that we can see the connector, or the original connectors, and then we'll see what's going on with the original design and what we've got to change so that we can connect this to our system. Okay, so here's the little bit of electronics remaining from the original design. We've got 2 connectors here, labelled COM1 and COM2, and we've got this little chip and the capacitor over here. So one of these connectors, I'm almost certain, is just going to be the 8 diodes in the first group, which means it will be continued way along for all the other groups. So if we just pick a pin out of this, start with the first one, and see if this is connected to any of the diodes. Okay, so it isn't. That's probably doing something else. Then let's try the second one. Okay, so that's connected to that diode, which is the, yep, so that's the first note in this particular group. And in fact, the way we're looking at it here, this is the top C, because the keyboard's upside down. So this is top C, bottom C is down that end. So this is actually, it's the last note, if you want. So that pin there, whichever one it was, where were we? Wrong connector. Let's try this one. So that's the last one. So there's a good chance that it follows its way along, and it does. Okay, and then the next diode is going to be the same as the first diode, so we're back to here again, and so on and so forth. So we can happily say that because it's upside down, as we said, it's back to front, the first C, if you like, is going to be that one. So that's the first diode, second, third, fourth, fifth, sixth, seventh, eighth. Then it will start over again, 9, 10, 11, 12, 13, 14, 15, 16, 17, and so on and so on and so on. So this connector here contains all 8 rows of our matrix. So that's nice and easy. We can just connect that to our circuit board or to our controller. So now we need to look at the columns. So the columns are these bars here, if you want. So if we just take one of those at random and see if that appears on any of these other connections, which it doesn't, so that's probably going to be connecting to this chip somewhere, because obviously we said our rows directly come to here, so this chip is obviously working with our columns. So let's see if, just bend that out of the way, it connects to one of these pins, and it doesn't. So this side, there we are, so that connects to that pin. Okay, so the next one along, it probably connects to the next pin. It does. And so on. So that's how that's going to work. This chip is a 74HC138N, and if we look that up, okay, so this chip 74138 is a 3 to 8 line decoder or demultiplexer. So basically what that means is that by putting a 3-bit address on some of these pins, I don't know which ones without looking it up, it will connect one of these inputs to its common line, if you want, one after the other if you increase the addresses on here incrementally. So they're using this basically to get all of this data down one line rather than down 8 lines. Not sure why they've done that really. You're not going to gain much because they've got 18 connectors on, or 18 connections on these sockets, and by doing it this way, yeah, the original way, I mean 8 by 8 would give you 16 connections. However, looking at this here, and it's marked on the board choir, swell and great, this is the swell key link across there, so I imagine that they're probably scanning all the, well, 2 keyboards in the case of this organ. There's presumably another model that has 3, and they're just scanning these together, and so that's where all this comes into play. Anyway, none of that's really relevant for what we're doing, because we require to be able to connect to these 8 columns directly to our board. So we need to remove this chip, and then we can connect to where these columns are on the chip. We could of course just solder wires to here if we wanted to, but it's then we've got cable management issues and it's not going to look as nice, etc. And we could also leave the chip in here and we could just solder across those pins, but I'm not a great fan of doing that, because if this chip fails internally, and it might well do because we're putting voltages on it and it has no supply voltage or anything else connected, we don't really know how it's going to behave, so we don't want any problems in the future. So what I'm going to do is I'm going to cut this chip out. It's almost impossible to get this whole circuit board out and unsolder this chip, and the reason for that is that these little springs, obviously they're just little springs, they're fixed in the end of these plastic clips, and they're very well fixed in the end of these plastic clips. I don't want to break it, so obviously to get the board out I'd have to remove all 61 of these, and the chances of some disaster occurring along the line there is not good. Secondly, these common lines, bus bars, whatever, are fixed into these plastic parts, and these plastic parts are fitted to the metal chassis. So again, you'd have to push these out of these plastic parts, and as you can see, hopefully, you know, they're pretty well in there. So I don't want to cause any damage to any of that. So by far the easiest way, we don't need this chip anymore, it's totally disposable. So I'm just going to use a Dremel and cut along these pins, both sides, and then we can solder directly to the pins that are left sticking out of the board, and I don't need to remove the board. Also, I'm going to cut this capacitor off because we don't need that anymore. And that's pretty much it really. That's what we're going to do, and that will then give us our 8 rows and our 8 columns. So I'm not going to do that on camera, because cutting these things with a sort of rotary tool is going to create a lot of dust, and it's not nice dust. I don't want to breathe any of it in, and even if I wear a mask or something, it's still going to end up getting over everything in the workshop around this area. So I'm going to take that outside and do that, and then we'll have a look at it when we've got rid of that. Okay, so I've cut this chip out and remove this capacitor now. This is actually the other keyboard. Obviously there's 2 of them, one for the great and one for the swell, and this one is the one that I've done. So since it's the first one, I thought I'd just show you the filming of this very quickly. So the only connections we need are this one here, which is to this shortened bus, and then these 7 along here. That top one there is not connected to the bus. That would have been the plus volt supply to the chip, so we don't need that. Likewise, that one at the end would have been 0 volts. That's all those chips are the same, but the ones we're interested in is that one and then these 7. So I'm going to solder directly to these and directly to these, and then connect the other ends of those wires to our keyboard interface. So let's have a look at the keyboard interface next, just see how that works, and then once we've done that I'll solder it together and we'll see this keyboard working, hopefully. Okay, so here's one of the Matrix keyboard interface boards, and as you can see it's got 8 connections for the columns along the bottom, 8 connections for the rows along the top, and then we've got header pins that we can connect to, and also there's a TUTI compatible interface here, so if we wanted to use TUTI connection strips to make our connections and to create the matrix, then we could plug one of those in here and connect to that. But we're not going to do that because, as we've just seen, we've got the keyboard, it's got all the diodes on board, so all we need to do is connect those rows and columns to our keyboard. So if we look at the computer screen, we can see straight away that when we turn the thing on with this connected to it, it comes up and tells us that matrix keyboard number 0 exists and that it's active low. And we have a polarity jumper here, so we can change the polarity dependent on which way round the diodes are on our keyboard. That determines which way we need to set this, but in the case of this one, it's active low. And it also says that there are 0 bus keyboards connected, because with the System ONE we can connect bus keyboards and matrix keyboards, whichever sort we want, and we can have up to 7 keyboards in total. That's made up of however many bus keyboards, however many matrix keyboards that we want, because we can just daisy chain these things together. So this obviously goes to the control board. We could take another one of these, and we will take another one of these for the second keyboard, and then we'll just have a cable that comes from this one to that one and so on, and that's how these are designed to work. So it says that we've got 0 bus keyboards, 1 matrix keyboard, and 1 total keyboards in use, and that the keyboard scanning module is ready. So if we connect column 1 to row 1, then you can see that we get a note keyboard 0, note 36 on, and then when we release it we get note off, and then row 2 will give us note 37, and 38, 39, 40, 41 and so on. That takes us up to 43, and then when we go to column 2, row 1, it carries on at 44 and so on. So that's how that works. We'll get this connected up to the keyboard, and then we can see the whole thing in action by pressing the keys on the keyboard and seeing the result on the computer. Okay, so we've got the keyboard interface wired up now, so we've got our 8 columns, or commons, whichever way you want to call them. I suppose technically they're columns, and we've got our 8 rows here, and they're connected to our 8 column inputs here and our 8 row inputs there. And then this is plugged into the main control board, which is over here out of shot. So if we look at the computer screen again, we can see it says as before 1 matrix keyboard, but this time if we press a note, you can see pressing the note there, and you can see that that comes up on the keyboard. And if we start right down at this end, so this is low C, so that's note 36. And then middle C, wherever that is, somewhere around here, close, that's note 60, which is middle C there. The reason that you get lots of them coming up on the screen is because I'm just pressing it gently. If I press it quite hard, it's a bit more positive, but I think these contacts are a little bit dirty, and I think also it hasn't been played for a while, so I'll probably go through and just give them a little bit of a clean up before we put it back into the actual organ. But you can see there, that's how it works, and obviously it is working as expected. So I'll do the other keyboard now, which I won't bother to film because it's going to be exactly the same as this one, and then I'll put them back in the organ, and we'll be able to see where we go from there. So here we have the keyboards mounted back in the organ, and if we take a look underneath them, we can see here's our wiring that we looked at earlier. This comes back down to the first interface back to the controller, and then for the lower keyboard or the grate, again exactly the same wiring back to the second interface. And then this is the cable for the piston rail. You'll remember we looked at that earlier, so that's now fitted correctly back into the organ, and everything just folds down. Obviously we've left a little bit of slack on these cables to allow the keyboards to hinge up and down. And the 2 interface cards or boards, you can see are just down on the left hand side here, and if I just zoom in a little bit, we'll be able to see them a bit better. So you can see how they're connected together. These are just ordinary RJ45 Ethernet type connections. So there's a very short lead, Ethernet lead, that just connects those two boards together, and that one's for the swell, that one's for the grate, and then this socket here will connect back via another Ethernet type cable to the main System ONE control board. So as far as our keyboards are concerned, that's all done. These two keys seem to have a bit of a problem. I've been cleaning them over time, but they're still a bit unreliable and intermittent, so that's why we've got those little markers on there, just to identify them, so I can put in a little bit more work on those and see if we can get them to work a bit more reliably. But there we are, that's the keyboards mounted and ready to go.